Okay, let's continue with calculation of probabilities. I'll let you just read this example here, so you can stop the video and read that, and then you can also read this one. Okay, a candy dish contains 1 yellow and 2 red candies, so 1 yellow and 2 red. You close your eyes, choose 2 candies one at a time. So you take one, and then you take another, and record their colors. What is the probability that both candies are red? So first of all, we need to figure out what the sample space is. So we do the same kind of tree diagram. We have, we can get red 1, red 2, or yellow. And then if we get red 1, we can't get red 1 again because we already took it out of the bowl. So we can either get red 2 or yellow, and so on with this R2. We can't get R2 again, and so on. So we get R1, R2 as one possibility, R1Y, R2, R1, and so on. All of these. How many are there? There are 6. We're going to assume that they're all equally likely because I'm not assuming it. They are all equally likely because we're doing this randomly. So each of these, there are 6 of them, so they must all have probability 1/6. And then the question was, I guess I'm going to finish this problem. The question is, what is the probability that both candies are red? So how many out of the 6 of them, how many of them have 2 red? This one does, and this one does, and those are the only 2. So the probability is 1/6 plus 1/6. There are 2 ways to do it. Each of them has probability 1/6. So it's 1/6 plus 1/6, which is 1/3. So what's the probability of getting exactly 2 red? 1/3. Calculating the probability of an event. List all the simple events in the sample space. This is like how to do this. How to calculate the probability of an event. It's a kind of 4-step process that they give us. So first of all, you list all the events, all the simple events in the sample space. So we list them. By the way, in other books, they call them all the different possible outcomes. I guess they also call them simple events. Okay. Assign an appropriate probability to each simple event. So somehow you need to figure out what is the probability of this, 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 and so on. Now we said that each one of these was 1/6, but that's because we said something about at random. But it doesn't always have to be that the simple events all have the same probabilities. Not at all. For example, if you don't have a fair coin and you go back and you do the other example, you wouldn't necessarily all have the same probabilities. So these don't have to have the same, but if there are certain words in the problem, for example, when they say that everything is done at random, then if you think about it, these will have to be the same. But as I said, they don't always have to be the same. Okay, so anyway, though, you have to assign an appropriate probability to each of the simple events. Determine which simple events result in the event of interest. So here, the event of interest was getting 2 red. That's what the question asked. So we have to see which of these gives us exactly 2 red, and it's only these 2. So which events, determine which simple events result in the event of interest. And 4, sum the probabilities of the simple events that result in the event of interest. So that's what we did. We added 1/6 plus 1/6. So they give us 2 things to follow here. Include all simple events in the sample space. So don't forget when you're calculating the sample, when you're figuring out what the sample space is, don't leave anything out. And assign realistic probabilities to the simple events. When the sample space is large, it's easy to unintentionally omit some of the simple events. If this happens, or if you assign probabilities, your assigned probabilities are wrong, your answers will not be useful in practice. One way to determine the required number of simple events is to use the counting rules presented in the next optional section. These rules can be used to solve more complex problems, which generally involve a large number of simple events. Okay, so if you need to only master the basic concepts, you can skip that. So if you want to look at some examples, here's one. Basketball player simple events. You can go through this and try and do this problem. If you have questions, you can email me. Here's another one, and some other ones here. Okay, you can try these out. Okay, now I'll scroll through this, but I'm not going to go through it. So if you want to read it, you can.